I know you just love all of this polymorphism and inheritance, so we're going to keep going. We're slowly getting to the end of the basic topics. What we're going to look at in this video and the next video is something called abstract classes. Now, abstract classes, they're not hard at all. Let's just go show you with a couple of code examples. In NetBeans, one of the examples that was coded out in your sample folder was something called Shapes Example 1. You probably did a couple practice questions about it before watching this video. Just to review the basics of it, we had a class called Shape. Somebody wanted to make some sort of program that will draw shapes onto the screen, like circles, rectangles, trapezoids, triangles, stuff like that. So they started this idea. They made this class called Shape, and you'll see it as a constructor, and it has methods like getX, getY for its X and Y position that it has up here. It has some methods like setX, setY, so you can set where you want it to draw, get how many sides, a method to move the shape around, and then some methods like getArea, getPerimeter, and draw. The person wants all the subclasses to be able to run this method getArea, getPerimeter, and draw. The problem is the shape class isn't actually a shape. They've just set this up to be a class that can have subclasses. Subclasses like circle. Circle extends shape. And by extending shape, it got things like the X and the Y position. It got the variable sides. And you'll see here eventually it codes getArea, getPerimeter, and draw. Remember, these are overrided, right? They were in the shape class with sort of some junk code because the user wanted to make sure those methods were there. But what they did in the circle class was they actually put the proper code. And that really ends the circle class. Here I've done a parallelogram class. I've added a little to it. So parallelograms get a few extra variables off of the shape class. And they also coded getArea, getPerimeter, and draw to match those methods in the shape class. Plus they have a few extra ones, isRectangle and isSquare. Now, the problem with this setup is this thing right here. It's not totally bad. I mean, it'll work, but shape isn't actually an actual shape like a circle or a square or a rectangle or a triangle. It's just this base class that all the other ones build off of. So when we look at this here, it has this kind of layout right now in the project. And so it's just sort of used as a base class because you don't want the circle, the colored circle, and the parallelogram all to have to code move and get sides and setX and getX and XY and sides. That stuff is all the same for all shapes that you could ever probably think of and make. That code is going to be exactly the same. That's why they decided to do the shape class up here as the superclass. But they also wanted their shapes to be able to have the area, perimeter, and draw. So they added that in there. This is because they didn't know about abstract classes. Here's a second version of the project that handles this idea of when you have some code that you'd love everybody to share, and then you have some methods that you'd like everybody to have, but not necessarily you can code them yourself right now. Because really a shape, how do you getArea? You don't even know what shape you are at this point. So here's the second project and the solution to it. What we do is we're going to close these and we're going to go to Shape Examples 2. Here's how I've changed the shape class in this project. I've declared the shape class as abstract. And soon as you do that, there's a rule. You cannot make or instantiate a instance of the shape class. And that's this slide rule right here. Can't instantiate an instance of an abstract class. Now, if you're not good on your definitions, here's what it means. It means if I went to the runner, that this line right here does not work. Let's just take these two out for now. You cannot do this. A new shape. You're not allowed to do it because shape is abstract. So another reason somebody might make an abstract class is they don't want anybody to ever make one. of that specific type. But anyways, why can't you make it? Well, here's why you can't make it. If we go and look at it in Shape Examples 2, our abstract shape class has the variables, good, constructors, totally fine, and then check this out. It has all those methods that'll be common to every subclass. So the ones you want all the subclasses to get. Get X, get Y, set, get sides, move. But what you don't have coded here is you don't have coded anymore these three. Get area, get perimeter, and draw. I want every single shape I ever make to have these, but I don't know what the code for these is going to be at this point. Every different shape is going to have a different equation for area and perimeter, and the draw method is definitely going to be different for each one. So what I do is I declare them as abstract. And as soon as you declare them as abstract, look at the signature here. No curly braces. You don't put no code like I had before in the old file. All you do is you just do that. You write the signature for the method. And once you've written that signature, what it's saying is it's saying if you decide now that you are going to build off of the shape class by extending, so circle extends shape, you're still going to get all the stuff you get, and you're basically required to implement those, which means to code them and have them inside your class. If you don't code them, you don't get to be a class. So for example, let's check out the circle class. Circle extends shape. You can still do that. I still get to add variables and have my own little constructors, whatever you want. And there I go. I've coded those three methods. Just pretend that one is coded there, right? But I've given them code. And that's enough. It satisfies it. Look what happens if I don't code getArea. If I take this out, the class is going to turn red and it says circle is not abstract, because I didn't put abstract class, I just put class. It's not abstract, and it's letting me know I have not overridden abstract method getArea in shape. It knows, no, you cannot be a class unless you are fully coded. And for circle to be fully coded, you need to code all the abstract methods that were listed in shape. What this does for the programmer is once I do it, yep, all those abstract methods are coded. I have satisfied the requirements to be a shape. So while a shape itself has no code for these, everything that extends shape should have those coded up. And if they don't code it up, like let's say I took that out again, you cannot call yourself a class. You must also call yourself an abstract class because you're not finished. So let's say you leave it like this. Maybe you have a class that extends off of circle. It would have to finish off that getArea method, and it could be a class. But that's the basic rule with abstract. So what you often find, a good general rule is, an abstract class will generally have some stuff coded, and it'll have some abstract methods, which are not coded, or you'd read on the exam it would say they're not implemented. Okay, they're just listed. That's your basic on abstract, just to get you started on it. If I go to a runner, just to show you that everything still works nicely, so I cannot do that line, right? You can't make a shape. Shape has incomplete code. It's abstract. So don't ever think of doing that. But you can do this. You could say shape S is a new circle. That's totally fine, because circle is a shape. It satisfies it, so that's all good. You could do circle C is a new circle. That's totally fine. I mean, everything's going to work here. You know, you keep going down the list. It's just your basic inheritance rules that you guys have gone over before. Anyways, that's the abstract class. Now, if we go back to the notes here, you can't instantiate an instance of it. So you've seen that. What is it good for? Just like when you extend, it's a good way to share fields, methods, and behavior that is going to be common to all the subclasses. So generally you have to have a project that probably has a little bit of size to it, right? You have a couple classes, and you're going to have classes that do the exact same thing. and so that way they get to share some of that code. Now, sometimes that's not always true. There's no common code to share, but sometimes it's important for this. It makes it clear that subclasses are going to have different implementations of the same method titles, and those are the abstract methods. So like with our circle here, you saw that with, I should say with our shape, you saw that all the subclasses, I want them, I'll require them to do that. But I don't have the code for it now. They're all going to implement it different. Anyways, bit of a long video, but that's basically the nutshell of the abstract class. So if you ever see an abstract class when you're going through docs or using classes, don't try to make one. Go look at its subclasses, and it's the subclasses that you'll probably be able to instantiate, create, and use. There you go. Have fun with that knowledge now of your abstract classes. And I think in the next video I'll go over a little example with the student teacher, which I've modified to have abstract as well, just to re-emphasize some of these points. Thanks for watching.